Welcome, welcome, welcome back, students. Happy New Year. Hopefully, you had a great one. We are dealing with Chapter 3 to start off our new unit, which is about number relationships. And we're going to be dealing with the different relationships with, guess what? Ha! Numbers! Okay, so can we go to 3.1 or Lesson 1? Lesson 1 is all about identifying factors. There are going to be two different methods of us trying to figure out how these factors work. The first method is using an array or using arrays. The second method is using a factor rainbow. Let's use a factor rainbow. Now, both these methods, they're really great at trying to identify the factors for different multiples. Let's walk through each one and see which one you prefer to use. Now, the great thing about using the arrays method is that it's very visual. If you like taking a look and organizing things visually, arrays probably is the perfect method for you. So let's take a look using a family favorite of ours, this picture. Yes, this is my deal with it picture. Isn't it so fitting? Okay, so we're going to get 12 of these deal with it pictures, and we're going to arrange them in an array. So let's make 12 of these. Okay, now what we want to do with an array is trying to put these in as many even rows as possible. So now that I have 12, let's count them up. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Deal with it pictures. Now I'm going to start moving them so that we can get even rows. And those even rows are going to tell us how many factors we have. So let me try this. I'm going to take this one. I've got, let's make a row of 1 first. We can, of course, make an even row of 1. I might have to start stacking it because we're running out of space really quickly, and Miss Nicanor has to deal with it. Okay, so the first one that we have is, let's see, we have got 1 row of 12. Okay, so we've got 1 array. Let me write that down. We've got 1. We've got 1 array there. All right, can we make a second one an evenly, let me write this down, and a second one, an evenly distributed row of 2. Can we do that? Let's try it out. Okay, so we're going to make 2 rows now, and we're going to make it even. So let's start off with this one, just like that. And let's distribute 12 evenly. So that one should go under there, that one should go under there, and perfect. We have an even distributed row of 2. 1, 2, 3, 4, 5, 6. So now we have 6 in this row. Can we do it with 3? So let's try that out with 3. Okay, let's see if that works. Let's do this. 1, 2, 3. And all we're doing is distributing 3 rows evenly, just like that. How many do we have? We've got 3 rows, 1, 2, 3, of how many pictures? 1, 2, 3, 4. We've got 3, whoops, let's change that color just so it's unified. 3 rows of 4, sorry. 3 rows of 4. And it's going to be the same thing if we did 4. So it's, this is flipped because 4 times 3 is the same thing. If we did 5, could we do a row of 5? Let's try that. Could we do a row of 5? Let's see. If we took this picture, 1, 2, 3, we got to move it really closely. 1, 2, 3, 4, 5. I'm not sure if we're going to have enough room for 5, but let's try it. So, can we make it even? What do you guys think? Ooh. As you can see, it's not evenly distributed. So therefore, we cannot have 5. That does not work. So in total, let's do that again. Let's just erase this. Can I erase that? Yes, perfect. Okay, now let me move some of these pictures just over here, just so we can see the arrays that we have. Okay. Now what we have here, we've got 3 different arrays. If we want to do 4 rows of 3, because we know that it's backwards, we can also write that down. So our fourth one would be 4 rows of 3. And we know that we can't do 5, so in total, we've got 4 arrays here. And what are the factors? We can write out the factors now, and they would be identified right here. We've got 1, 12, 2, 6, 3, 4, and 4 and 3. We don't need to add that because we know that they're the same. The factors would be 4, 6, and the last one is 12. So these right here are the factors using how many arrays? Can you show me with your fingers? That's right, 4 arrays. We were able to find the factors, 1, 2, 3, 4, 6, and 12. Perfect. We are now moving on to factor rainbows. If you found the last part a little bit confusing, I would suggest to go to your textbook, page 70 to 71, and do the example there, or just rewatch the last part where we're identifying factors through arrays. Right now, we're going to do another method of trying to find factors, and that is through factor rainbows. Factor rainbows is going to deal heavily with your understanding of the multiplication table. If you're not really familiar with it or as good as you'd like to be, what I suggest is to have either a calculator or have your multiplication table out in front of you. We're going to start off, just like the arrays, with the number 1. If we're trying to find the factors of the number 15, let's start off with the number 1 like I said earlier. So here's number 1. Just like that. And we know that 15 times 1 equals 15. Every time we multiply, we want this rainbow right here to equal 15. Just like that. So what would 2 equal? Is there? What's 2 times something equals 15? Nope, there is none. So we would erase that. Does 3 equal something? So 3 times what? That's right, 5 equals 15. And what's next? Let's try 4. Does 4 equal something? Nope. And we know that 5 and 3 equal the same thing. So we don't have to do 5 and 3 because it doesn't go backwards. So now, using this method, we've figured out that the factors of 15 are 1, 3, 5, and 15. Those are your factors. Now let's try the same number that we tried last time with the arrays, which was the number 12. And let's see if we can come up with the exact same factors using a factor rainbow instead of the array that we used last time. All right, let's start with the number 12 right up here. And like I said, let's start off with the number 1. 1 times 12 equals 12. Of course we know that. Here we go. There's your rainbow. Let's start off with the number 2. Does 2 times something equal 12? If you said 6, that's perfect. Does 3 times something equal 12? And if you said 4, that's great. And just like last time with the array, we found out that 1, 2, 3, 4, 6, and 12 are the factors. Now, there's no right or wrong method that you have to choose. If you are more visual and you like arranging things, then arrays might be your best bet. If you want the quick and dirty way of doing it really quickly because you're familiar with your times tables, you can do a factor rainbow to try and find out the factors. Each method is really strong in the way that you use them, and there's no right or wrong. All right, so if you didn't understand any parts of trying to figure out how to do a factor rainbow or an array, feel free to rewatch and pause this video as much as you need to. Have fun with the homework. If you have any questions, ask me tomorrow. All right, talk to you soon. Bye.